So the object is moving in that direction. You can take that as x-axis or a negative x-axis, doesn't matter. So you take this as x-axis, and y-axis is perpendicular to that. There are three forces acting, so because this is moving this way, friction is that way, and the acceleration is down the ramp, so the acceleration is this way. And friction force is this way, Fk, because it's moving, it has Fk, right? And then normal force is that way, and then gravity is this way, mg. And the angle of the ramp is turns out to be this angle. This turns out to be this angle, right? All right, so if you do sum of fx equal to max, what are the x components? N doesn't have x component. X component of mg is what?
mg sine theta.
mg sine theta, very good. Of course, negative, right?
Yeah.
I also thought that the x was this way. And then plus fk equal to m times x component of acceleration, which is negative a. If you multiply everything by negative sign, it is the same as taking the x-axis the other way. Right? We can multiply everything by a negative sign, so they get ma. But anyway, Fk, by definition, is equal to mu k times normal force, right? And if I multiply everything by a negative sign, I get mg sine theta minus mu k times normal force equals to ma. And you see, I don't know acceleration, and I don't know normal force. The rest of things are known, right? And then, what is the normal force? In order to find normal force, I have to analyze the other direction of motion. And that gives us sum of Fy equal to 0, because acceleration in y direction is 0, and that is equal to sum of Fy equals n minus, what is the y component of mg cosine theta? Right? And this friction force doesn't have y component, so that's all equal to 0. So that gives us n equal to mg cosine theta. And now that we know n, we put it here. So mg sine theta minus mu k n, which is mg cosine theta, equal to ma, right? And you see, every term has m. M can be cancelled. And therefore, a is what? Is g sine theta minus mu k g cosine theta. And also we can factor g and say g times sine theta minus mu k cosine theta. Right? And now if the object is going upward, what changes if you go uphill?
Friction, like direction.
Direction of friction switch over, right? The velocity is uphill, therefore the friction will be downhill. Your free body diagram, now this is your x direction. You have again the mg this way, theta, and you have friction downhill because we're going uphill. If the velocity is this way, the friction will be that way, k, and the normal force is this way. In the y direction, nothing changes, so n is still equal to mg cosine theta. Then sum of fx gives you negative mg sine theta minus mu k times normal force, which is mg cosine theta, equal to ma. Acceleration will be downward, so negative ma. And then the negative m cancels out. Acceleration will be has a magnitude of g sine theta plus mu k cosine theta. Right? If the acceleration is 0, means that if the angle is just enough to make the acceleration 0, what is the relationship between theta and mu? Actually, in this case, if acceleration is 0, what is mu k in terms of theta? Put that equal to 0 for mu k. If you put that equal to 0, then mu k cosine theta should be equal to sine theta. So mu k should be tan of theta. So when mu k equals tan theta, then a equal to 0. When it's going downhill. When it's going uphill, you cannot have the acceleration 0. This is the threshold angle. This is one way to measure the coefficient of friction. If you tilt something slowly until it starts moving, and until it moves at constant speed downhill, then the tan of that angle is mu k. That's one way to measure mu k. Another way to measure mu k is that when you have these motion sensors and stuff, you can measure acceleration as we did before. You can measure acceleration when it's going downhill, and measure acceleration when it's going uphill. The difference between these two relates to mu k, and you can calculate mu k.